So in this discussion, we look at some questions in paper 1 from the 2024, mathematics paper 1 question, and see how you can actually go about answering some of the few questions that people, find a bit challenging. But of course, they're not a bit challenging. You just need to follow what I'm doing, especially if you're writing your GCE this year, 2026. This can actually help you to stay focused. Many people fail paper 1, because they lack the concepts, to answer these questions adequately. The first question there says, solve the equation. So how do you solve such an equation? You need to remember the laws of indices. In this case, they have given us 3, 1 raised to the power 2x plus 4 is equal to 5. Like terms on one side. So this 4 can go the other side. It will be 3 raised to 1 minus 2x is equal to. So if you notice, if it actually goes, to the other side, then how is that going to, to become? So it is actually going to be a minus. So it will be 5 minus 4. So it is going to be 5 minus 4. So it will be 3 raised to 1 minus 2x is equal to, and that will give us a 1. Now, of course, someone may say, I'm actually stuck. You shouldn't be stuck. According to the laws of indices, any number raised to the power 0 is equal to 1. And that's the concept that you have. Because the base this side is 3, I can also say 3 raised to the power 0, that is equal to 1. Meaning here where there's a 1, I can replace with 3 raised to the power 0. So it will be 3 raised to 1 minus 2x is equal to 3 raised to the power 0. You can see that the bases are the same, so you just compare the the powers, so to say, or the index or exponent. So it will be 1 minus 2x is equal to 0, and therefore we can find what x is. I can take this negative 2x to the other side. When I take it that side, it will become positive 2x. To find x, I'll divide to what I do this side, I'll do it the other side, meaning that x is equal to 1 over 2. And that's what you needed to do. Remember, no calculator that you needed to do. So the key idea, when you take this one the other side, you are coming with 1. But you need to remember the laws of indices. Any number, whatsoever number you may talk about, raised to the power 0 is equal to 1, and that's what I needed to treat. Where there's 1, I can replace with 3 raised to the power 0, and since the bases are the same, you compare, in this case, the exponents, and you can solve for the value of x. So that's the way you needed to go about that one. Let's look at number 1b and see how you again can solve that one. Again, it was saying solve the equation that was carrying 2 marks in this 2024 paper 1. How do you solve such an equation when you find 1 2t raised to the power 2 is equal to 20 is equal to 25? Well, you don't need to struggle. Right away you can get rid of that square that you're having by introducing the square root. What you do this side, you also do it the other side. But when you introduce the other side, the square root should either be positive or negative. So this and that will cancel. I'll remain with 1 minus 2t is equal to plus or minus the square root of 25 is a 5. So when you reach at that point, you can now separate them and say 1 minus 2t is equal to, you take the positive part of the square root, so that is equal to 5, or you can again take 1 minus 2t, and that would be equal to the negative part of the square root, so which is equal to negative 5. So you can solve these two now independently, but remember they are 1. So this one can go that side. I'll remain with negative 2t is equal to 5 minus 1. So it will be negative 2t is equal to 5 minus 1 is a 4. I'll divide negative 2. What I do this side, I'll do it the other side. So meaning t is equal to negative 2. We can also finish up this one here. This one can go that side, so it will be negative 2t is equal to negative 5 minus 1. Negative 2t will be equal to, remember, like terms, you add them, so that will be negative 6. To find t, I'll divide negative 2 so that I remain with just t. What I do on the left hand side, I'll do it on the right hand side. So meaning that t is equal to this negative, and that negative will cancel. 2 into 6 is 3. Therefore, t can either be -2 or it could be a 3. And that's what you needed to do there. It's not complicated, it's very simple. So right away, to get rid of that square, introduce the square root. But when you introduce the square root, the other side, it should either be positive or negative. So that's the way you needed to have gone about it. I hope we are together. Another aspect there, if you look at question number 2, we come to question number 2. It was saying factorize completely. Obviously, you'll be finding these questions factorizing completely, so you need to remember where a particular topic is coming from. Under factorization, you are going to be using more of difference of two squares. So let's look at that. It says 27y raised to the power 2 minus 3x squared. The first thing is to look at what is common. Is there anything common on the left hand side and the right hand side? One, you need to start with variables, a letter, and also look for the highest common factor that can go both sides if there's a number. For example, 3 can go into 27, so meaning 3 is actually common. Therefore, I'll move it out. When I move it out, I'll start dividing 3 to know what will remain. 3 into 27 is 9, and that would be y raised to the power 2 minus this 3, and that 3 will cancel, so I'll remain with x squared. But 9 is a square number. Remember, a square number is a number that can be written in the form n raised to the power 2. So when a number can be written in the form n raised to the power 2, we call it as being a square number. For example, 1 squared, 2 squared, 3 squared, 4 squared. 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. So you can see 9 is a square number because we can write it as 3 raised to the power 2. So here I'm going to say that 9 can be written as 3 raised to the power 2 and y raised to the power 2 minus x raised to the power 2. Now, if you remember the difference of two squares, it says if you have got a squared minus b squared, then this can be factorized. You get a there plus b. Again, you repeat, but this time using a different sign. That's the difference of two squares. So this can be written like that. Now, if you have such an idea of difference of two squares, what is in the bracket has been raised to the power 2. So therefore, we can write it as 3, open bracket, I'll get a 3, I'll get a y, plus here, I'll get x. Then I'll repeat again this 3y, but this time the sign will change. It simply means that you have now factorized that. So that's the way you can simply go about that one. You need to remember, first of all, start with the common factors, then try to see if you can apply difference of two squares. And in most cases, most of the questions, you may be using difference of two squares. I hope that is clear and you are able to get it there. And let's try to look at question number 3. It says simplify 3, then 2x minus 4, minus 2, then x minus 1. People make a mistakes with this and they end up getting a 0 for that. Look at how to do it. 3 times 2x will give me 6x, and 3 times -4 will give me a -12. Here, when it comes here, this is where people make a mistake. You take even the sign in front of the number. So it's -2 times x will give you -2x. -2 times -1 will change to a positive. So that would be a +2. Then you can add like terms. Remember, there's no equal sign, so the signs are not changing. You are moving the sign, the number with the sign in front. So this and that are like terms. So minus 2x, and this one here, -12, and this one here, which is a +2. So what is 6x minus 2x? It is 4x. The -12 plus 2, different signs, you subtract and get the sign from the bigger number. So that would be -10, and hence you go there. You have actually simplified that one. That's what it simply means there. I hope we are together. I think the space is enough. We can also do question number 2. It says evaluate. Again, this question that was saying evaluate, the laws of indices come to play. Look at this, -2 raised to the power 0 times negative 2 raised to the power negative 3. Now, if you remember, according to some laws of indices that you looked at, I said any number raised to the power 0, if any number is raised to the power 0, that is equal to 1. If you have got a raised to a negative index like that, that can change. That negative can be 1 over a raised to a positive index, and that's what we are going to treat that one there. We can actually treat it. Any number raised to the power 0 is actually 1 times, remember, this can be written as that negative from this row here will become 1 over negative 2, and it will be raised to a positive in the index. Now, if you remember, 1 over, what does negative 2 raised to the power 3 mean? It means negative 2 times negative 2 times negative 2. You multiply them 3 times. So it will be 1 times 1 over negative 2 times negative 2 is a positive 4. Positive 4 times negative 2 give me a negative 8. So when you multiply 1 times this, you are going to have negative 1 over 8. And this is the final answer that you needed to have there. So this is what you are going to have, negative 1 over 8, and that's the final answer that we are having there. So this is the final answer that you had. Remember, this means negative 2 times negative 2 times negative 2, which will give you 1 over negative 8, and 1 times that will give us that. But I want to emphasize something right here. I want to emphasize something. You know, students have actually been making a whole lot of mistakes when it comes to that. When you are substituting, enclose what you are substituting in bracket. Why? Because when you write negative 3 raised to, let me say, when you say negative 2 raised to the power 3 and negative 2 raised to the power 3, these are two different. They are not the same, they are two different. What that simply means is the negative is alone. What you are raising to the power 3 is the 2 times 2 times 2, and that will give you negative 8. That's what it simply means. Is that okay? But what about when you write it like this? It means negative 2 times negative 2 times negative 2. Yes, it is going to give you a negative 8 in this instant. But wait a minute, I want to show you, you know, what that is going to be. Suppose you have got 2, negative 2 raised to the power 2, and you write it as negative 2 raised to the power 2. Are those going to be the same? The answer is no. This means negative 2 times 2, and that will give you negative 4. But here it's the first one here actually means negative 2 times negative 2, which will give you a 4. But the second one here means the negative is outside 2 times 2, and that will give you a negative 4. So you can see these are two different expressions. They are not the same. Yes, if it is actually not even like it is, if the power is not even, you may actually have the same. The negative may still be maintained, but you need to be careful when it comes to that. Right, that's what I thought I could actually express. Let's move on to question number 5 there. So for question number 5 there, the question there says a straight line L is represented by the equation. So the straight line is represented by the equation for number 5, which is 2x minus y is equal to 5. Then the question says find the gradient of the line. So they just want you to find the gradient from that line they have given you. So how do you need to go about it? Well, for you to find the gradient, you need to rearrange this equation of a straight line in the general form, which is y is equal to mx plus c. Remember, this is the general form of an equation of a straight line where m is the gradient and c is representing what we call the y-intercept. In other words, make y the subject of the formula. So when you make y the subject of the formula, and the constant is always at the end, after the equal sign, the one having x is the one that is going to be there. You can identify the gradient. Let's see how that is going to be. So we have got 2x minus y is equal to 5. So this x 2x will go the other side, so I'll remain with negative y is equal to, the sign will change, it will be negative 2x. This 5 will be pushed the far end, it is having positive, that's why I've written positive 5. We just want to remain with y, so I'll divide throughout by negative 1. There's a negative 1 there, so I'll divide throughout by negative 1. So it will be y is equal to negative and negative cancel, so it will be 2x. Positive and negative is negative 5. 1 into 5, you know that is 5. So when you write it in this form, then the number in front of x, that's the gradient, So what's the gradient from there? What's the gradient m there? The number in front of x, it's 2. Yes, then it means that you have identified what your gradient is. So just make y the subject of the formula and identify the number in front of x that represent your gradient. That's what we mean. Okay, let's move on to question number 6. Not the least one, but that is the basic question that I actually did there. It was saying that the equation of the curve, this is under calculus. What we previously did is under coordinate geometry. The equation of the curve, so they have given you the equation of the curve y is equal to x minus 2x squared plus 1 over x raised to the power 3. Then it says that we find dy over dx. dy over dx is simply the derivative or the gradient in simple terms. So they want you to find the gradient. Now before we can work out that we can find dy over dx, the gradient, so to say the derivative with respect to x, you first of all need to drop this one. Now remember, according to the laws of indices, if you have got x raised to the power negative n, this can be written, that negative will become 1 over x raised to the positive index. So if you can go in that direction, it means if I have this, I can bring it back like this, and that's what we are going to do also here. So we are going to say, before we find dy over dx, it will be x minus 2x squared plus that one, I'll drop it down, it will become x minus 3. So once you drop it like this, now you can find your dy over dx. Otherwise, that's where people have challenges. Remember, when you're finding dy over dx, may I simply remind you, if you have got y is equal to ax raised to the power n, and you want to find dy over dx, it's the power, so that power n multiplies by the coefficient in front, na, then the power should always reduce by 1. That's the key idea when we are differentiating, finding the derivative. So if you have just the number there, the number, if you have just the letter, it will become just 1. Then this will be 2 times. Why am I saying it will become 1? Someone may be wondering. Remember, if you have x, you have 1 on top there, which you can see. 1 times 1 is 1, but 1 minus 1 will give you x raised to the power 0. Any number raised to the power 0 is what? 1. And that's why if you just have a letter, when you differentiate it, you just remain with the 1. That's the idea there. So here, when I differentiate that one, I'll just have 1. Then this will be 2 times negative 2, give me negative 4. The power will reduce, 2 minus 1, I'll remain with 1. We don't write, show 1 there. Then this will be negative 3 times the 1 in front there, which you cannot see, so this will change to negative 3x. But if you look at this one, it will be negative 3 minus 1, so the power will increase to minus what? Will increase to minus 4. So that's what we mean. So you can leave it there, or you can go further and say 1 minus 4x. This could have actually been brought back to that. So we could also write it as negative 3 over x raised to the power 4, if you are familiar with that. If you wanted, you could have ended it here, or you could have also ended it there. There's no problem, whichever you feel like you are comfortable with. Thank you so much for watching. If you are writing GCE, please watch out my videos so that you are able to learn and get the concept that you need to pass your exams. Watch out for more mathematics videos, even physics, chemistry, biology. For those of you that are doing pure science, we also tutor in pure sciences, physics, chemistry, and also additional mathematics. you can watch out my videos as well. Thank you so much for watching.